friends, it's Miss Martin. I just want to talk you through multiplying by powers of 10 and finding the pattern. So this is just an anchor chart showing how and when multiplying by powers of 10, your decimal is going to move to the right for each zero. So what you see here is that with 5.26 or 5 and 26 hundredths times 10, there's 1 0, right, as they said. So there's that 1 0. And so that means my decimal moves one time, right? So in the answer, you can see that that's what happened right here too, okay? So now it's 52 and 6/10, all right? Now, in the next one, we still have 5 and 26 hundredths times 100. Well, that has 2 zeros, right? So we're going to move twice. 1, 2. If it helps, you can think of the moves as skipping over a digit. We're going to skip over 2 digits, okay, to move spots. So I had to skip the 2 and skip the 6. And now it's 526. You don't need any zeros behind the decimal, so you could just leave them off if they were there. And then, so if you look at the next one, 5 and 26 hundredths times 1,000. Well, that's got 3 whole zeros. So that means I'm going to jump 3 times. 1 digit, 2 digits. Uh-oh, there's nothing there, right? That's an empty place. Well, every time we end up with an empty place, we all know that we fill that place with a, good, hopefully you said 0. So we fill that place with a 0. So in my brain, or even on a piece of paper, if I'm using a piece of paper, I can fill that place with a 0. Because that's a place maker 0. I have to move the decimal one more spot. Otherwise, if I don't move the decimal one more spot, I would still have this. 5, 2, 6. Okay? And then I put my decimal there. Well, guess what? That's the same as this, but I'm not, it can't be the same because I'm not multiplying by 100. I need another place. So there has to be something to make that place. So 0, and then I put my decimal. Now my decimal has moved 3 times. I just needed to fill that extra space, which is why my answer would be 5,260 now. Okay, so that's just talking about that. Our numbers should always be getting bigger when we're multiplying by powers of 10 that are greater than 1. So now let's look at, those drawings, and let's look at this example, okay? Let me see if I can make it bigger. Yep, there we go. All right, so on here, now we have exponents this time. So if you remember how exponents work, you're really just looking at the number, okay? And the number tells you, the exponent tells you how many times to move. So this exponent is 0, which means how many times do we move? 0 times. Good. So that means that this decimal is going to stay exactly where it's at. So in my answer, it's still going to be 4.7 because the 0 exponent told me I didn't have to move it. Now let's look at this next one. Our exponent is 1. That means 10 to the first power has 1 0, and that means I will have to move my decimal 1 time. So right here, it's going to have to skip 1 digit. Boom. That means we're going to skip the 7. The decimal is going to end up right behind the 7, which means 4, 7 decimal. But we know that that means it's a whole number, right? When the decimal's at the end, I don't have to use that. I don't have to put that decimal there. It can actually just disappear because in most whole numbers, it does disappear. So we'll just get rid of that because we don't need it. So now let's look at this next problem. We've got 10 to the second power, 2, right? My exponent says 2, so that means I need to move my decimal 2 times. Okay, so right here, I'm going to skip 2 digits. Skip the 7. Uh-oh, skip a blank. What do we put in the blank? Hopefully you said 0 because you got it. We need a place maker 0. That means over here, it's going to be 4. Oh, sorry, that's the 7. 470, okay? And I could place my decimal point right there, right? I can place it there because this is a whole number, but we know that whole numbers don't need them. So I'm just going to erase it because they're usually invisible on whole numbers. All right, let's look at this next one. We've got 4.7 or 4 7/10 times 10 to the third power. That exponent tells us that we need to move our decimal 3 times this time. Okay, and we're multiplying, so we're moving to the right. So jump the 7, jump a blank, and jump another blank. Well, both of those blanks need to be filled with zeros. So that's 1 0 and 2 zeros. Okay, so when I get over here, that is 4, 7 with 2 zeros. All right, technically my decimal is at the back, but we know that on whole numbers, we don't need that. So I'm going to hit get rid of that, and I can just write in my comma, right? Because that's 4,000, 700. All right, that is how you do that. So once you hit the whole numbers, your decimal does kind of disappear, but that's when we revert back to when we're dealing with a whole number, you need to add a 0, okay? But if you notice, because I had one decimal in this problem, the zeros don't match exactly because I started with a decimal. So remember that when your initial number, that number in front is a decimal, think about moving the decimal or jumping digits, not necessarily just about adding zeros. Because when you add a 0, you're really just making an equivalent decimal, okay? And I'll kind of show you that in the next one too. I'll show you that mistake. All right, let's clear these drawings and move to the last example. All right, let's look at this example. So this one, we're going to do the same thing. I'm just going to show you what it means when you add a 0 to an already existing decimal, okay? So in this first one, well, we can actually kind of tell there are no zeros in 1. That means our decimal point doesn't move. And we should also know that this is the, let me see if I can write it, identity property, okay? That's what this is. Any number times 1 is itself. So even without thinking about the number of zeros, anytime you see anything multiplied by 1, that's always going to be the same number. So in my answer, I can just put the same number, 1.2, 1 2/10, okay? Because that one doesn't have one. So let's look at our second one. That's got a 0, 1 0, which means I need to move my decimal 1. I need to jump 1 digit. I'm going to jump that 2 because I know my number should be getting bigger. I should have more digits in front of the decimal. Okay, so I'm going to move it over. Now, here's what happens if you don't move the decimal and you just add a 0. If you don't move the decimal and you just add a 0, if I hit undo and you forget to do it, here's what happens. You end up with 1.20. But guess what? Zeros behind the decimal don't count for anything. Behind all the digits behind the decimal, these are actually just equivalent numbers. But I know that if I have 1.2 10 times, I shouldn't end up with the same thing. That means I should end up with more. So this doesn't make any sense. You're actually just writing an equivalent decimal. So this is wrong. Right? Get rid of that. We don't want that. We don't add zeros when it's a decimal. Instead, we want to move the decimal, okay? Hold on. Okay, so like I said, with that 1 0, we're going to move that decimal 1 time. I'm going to jump that 1 digit. Now it's going to end up behind the 2. So I know that I'll have 1, 2, decimal. But we know that now that's a whole number. That's the number 12, and I can get rid of that decimal. Undo. Get rid of that. I don't need it. It's a whole number. It's 12. Okay, now look at the next one. 100, it's got 2 zeros, so I'm going to move twice. I'm gonna skip over the 2. Uh-oh, I'm out of digits, but that's fine. I can still skip. That just means I have an empty space, which I need to fill with a 0. You got it. I need to fill that space with a 0, okay? So that is 1, 2, 0, and then my decimal's at the back. But 120, again, that's a whole number. I don't need that decimal at the back. I can get rid of it because that's a whole number. Okay, let's look over here. Where am I? There we go. 1 2/10 times 1,000. Well, 1,000, that's got 3 zeros. So I'm going to move 3 times. I'm going to skip 3 places. There's the 2, and then a blank place, and then another blank place. Well, that means I have 2 blank places. That is 2 zeros I need to put in. That is 1, 2, 0, 0. Sorry, that kind of looks like a 6. That's a 0. Decimal. All right. I could put my comma in there because it's actually 1,200, but I do know that I don't need that decimal. Sorry, put that comma back in there. Okay, that is 1,200. It's a whole number, so I don't need the decimal at the back because it's gone. I only need a decimal when there is a digit, a real digit that's not a 0, that's behind that decimal. That's the only time I keep it. Okay. All right, hopefully this has been helpful. Please make sure that you are practicing, watching the pattern of the decimal moving, okay? Yeah, and email me if you have questions. All right, thanks, friends.